Hello once again, everyone. This is the NPP Mission Science Briefing. And here to discuss the mission's goals and objectives of NPP is Jim Gleason, the NPP project scientist from NASA's Goddard Space Flight Center in Greenbelt, Maryland, and Mitch Goldberg, the NOAA Joint Polar Satellite System program scientist for the NOAA Satellite and Information Service in Silver Spring, Maryland. And we'll begin first with Jim Gleason, our project scientist from Goddard. Jim?
Thank you, George. We're very excited to be here today talking to you about the upcoming NPP launch, the first mission designed to provide observations for both weather forecasters and climate researchers. It's incredibly valuable to try to understand what the future environment may bring. And the future environment is as much about tomorrow's weather as it is long-term climate change. People often confuse weather and climate. Weather is what's going to happen tomorrow or this weekend. We just had a great weather forecast for launch. Everyone's very, very excited. Climate is what happens over years and decades. So climate is long-term behavior, weather patterns over time. These weather patterns are what make it easier to grow corn in Iowa than in Arizona. So put simply, climate is what you expect, weather is what you get. And the NPP mission and the NPP observations will help scientists better predict the future. And these future predictions are incredibly valuable for economic, security, and humanitarian reasons. So why is NPP important to NASA? NPP is important to NASA because it continues the over 40 years of observations of the Earth that NASA has been making, and in particular continues the decade-long observations from the Earth observation satellite systems Terra, Aqua, and Aura. And in the future, these observations will be continued by the JPSS satellites. So NPP's observations will produce at least 30 different data sets. They'll contribute to our understanding of all parts of the Earth system. They'll understand how temperature and water vapor are distributed in the atmosphere, how clouds and aerosols affect temperature, how NPP's observations will help us understand the ozone layer, and NPP's observations will help us understand the biosphere, focusing on vegetation on land and in the ocean. The workhorse of NPP is the VIIRS instrument, producing over 20 data products covering land, clouds, fires, and oceans. And the illustration shows the VIIRS instrument on the front of the NPP spacecraft. You will now see a series of images illustrating just a few of the many VIIRS data products that will be available. The images you're seeing are from the MODIS instruments on the EOS Terra and Aqua missions. And as Ken has said, because this data has proven to be so useful over the past decade, the VIIRS instrument was designed to continue to provide these incredibly valuable data products. And that's true for all the data products on the NPP mission. The Earth observing satellite system has demonstrated their value and their utility, which is why NPP will continue to make those observations. It's ozone hole season, and the ozone mapping and profiling suite, which should be coming up on the video, is the instrument on the back of the NPP spacecraft, looking aft as it aft for the limb and then down. And it's the ozone OMPS instrument will be mapping the ozone hole next year. This is what you're seeing now is a series of images from this year's ozone hole mapped by the OMI instrument on the EOS Aura spacecraft. So, and in addition to monitoring the ozone hole, the OMPS instrument will carry on the decades-long ozone record, helping us understand the long-term behavior of the ozone layer and basically helping us understand the effectiveness of the Montreal Protocol in controlling ozone-depleting substances like chlorofluorocarbons, which are found in air conditioners. So why is NPP important to you and your neighbors? NPP is important because it makes observations, and observations help us make better models, which then help us make a better prediction of what's going to happen. If we have a better prediction, we can make a better decision. And these decisions can be as simple as, do I bring an umbrella or as complex as how to adapt to a changing climate. So in short, NPP is better observations for better predictions to make better decisions. Thank you. Back
Thank
to
you,
George.
Jim. All right, now we will hear from Mitch Goldberg from NOAA. He is the Joint Polar Satellite System Program Scientist from the NOAA Satellite and Information Service. Mitch?
Thank you, George. The launch of NPP is critical for NOAA and NASA, for the United States, and for the international community. NPP represents a bridge from current NOAA operational and NASA research satellites to the future operational platforms known as the Joint Polar Satellite System, JPSS, and will provide essential and improved atmospheric, oceanic, and terrestrial observations for many different applications. The international community will also use NPP data to benefit their users. For example, NOAA has a very strong partnership with the European Operational Satellite Agency, EUMETSAT. They provide data to NOAA from their operational satellites, and likewise we provide data to them. Together we provide better global coverage of essential observations, enabling better weather forecasts and environmental assessments. NPP is particularly very important for weather forecasting. The accuracy of weather forecasts are based on advanced numerical weather prediction models running on the world's fastest computers, which are fed billions of observations per day and covering the entire globe. The backbone for those global observations is the polar satellite data that both NASA and NOAA have worked for decades to improve and to provide to the operational forecast community. Major advancements in the accuracy of weather forecasting has taken place in the last 30 years since the launch of the first NOAA operational polar satellites, and NPP will ensure that these improvements will continue and that there will be no degradation of forecast skill. Forecasts are used to make decisions in order to save lives, mitigate property loss, and make millions of day-to-day and longer-term decisions across all economic sectors affected by weather, such as transportation, agriculture, construction, energy, and tourism. In 2011 alone, there has been 10 separate weather events, each inflicting at least $1 billion in damages, including tornado outbreaks, fires, hurricanes, and floods, and blizzards. NPP will provide improved information to forecasters and emergency managers to better warn and prepare the public for severe weather events. With NPP observations feeding NOAA's operational weather prediction models, we expect to improve our forecast skills out to 5 to 7 days in advance of extreme weather events, including hurricane severe weather outbreaks. And we expect that the advanced microwave and infrared sounders, which provides critical atmospheric temperature and water vapor information, and the high spatial resolution imager on the NPP spacecraft to become the foundations of the global observing system that is absolutely essential for NOAA's weather prediction capabilities, especially for extreme events such as last August Hurricane Irene on the east coast of the United States. Beyond weather forecasting, NOAA will use NPP data to track ash plumes from volcanic eruptions, which of course is important for aviation safety, monitor fires, vegetation health, and droughts, and also to predict the potential for a prolonged period of drought and fire risk conditions, measure variations in the amount of Arctic sea ice. NPP data will also be used to detect harmful algae blooms and other hazards that might endanger fisheries and fragile coastal ecosystems, as well as human health. For example, there are approximately 50% more emergency room visits for respiratory illness during red tide events. NPP will measure global land, sea surface temperature, and clouds. As Dr. Gleason mentioned, it will provide key observations of stratospheric ozone for monitoring the ozone hole. And also the ozone data is used for providing warnings to the public on dangerous UV exposure from the sun. So in conclusion, NOAA is looking forward to a successful launch. We are very excited about the prospects for not only improved operational product and services, but NPP will provide essential data for research to better understand, predict, and adapt to our changing environment. We are also looking forward to the launch of GCOM-W by Japan next spring. NOAA will be using GCOM-W AMSR-2 microwave imager operationally for monitoring precipitation, total water vapor content, snow and ice cover, sea surface temperature, ocean wind speed, and soil moisture in all weather conditions. Furthermore, EUMETSAT will be launching their METOP-B satellite next year, so it's a very exciting year, not just for NOAA, for the United States and NASA, but also for our close international partners in Europe and Japan. Thank you.
Thank you, Mitch. And we're ready now to take questions. Once again, please give your name and affiliation when the microphone comes to you. We'll start here on this side with Nora.
Thank you. Nora Wallace, Santa Barbara News Press. I kind of feel like asking, what doesn't it do when you say everything that it does do? Can you talk to us about how improved NPP is compared to Terra, Aqua, and Aura? How much more advanced it is?
NPP is an equivalent to the combinations of it's really a combination of the measurements on the EOS Aqua platform and some of the measurements on the Aura platform. The difference is that is essentially this is the time for the generational leap forward in operational weather forecasting observations. The NASA satellites are research satellites. They're done once, maybe twice for these very large platforms, but in general we don't repeat them. So what's happened is over the past decade, the utility of these observations for weather forecasting and events has been proven. And it was just about time for NOAA to rebuild its satellite fleet and come up with the next generation. And they could do that with confidence because all of the observations and the data had been demonstrated as how well it would make the improvement. So for example, the research data from the AIRS instrument is done into the forecasts, and now the forecasters will have the confidence that the AIRS quality data will continue because the CRIS instrument will fly now and into the future. So it's basically keeping people, meeting people's expectations because they've enjoyed the quality data from the research satellites.
Additional questions? Janine.
Janine Scully, Santa Maria Times and Lompoc Record. Can you talk about how critical it is to get NPP up there in terms of what's the health status of the current orbiting NOAA satellites, which are getting pretty ancient?
Well, the current NOAA satellite is NOAA 19. That was launched in early 2009. It has a design life of about 3 years. So if you add 3 to 2009, it's 2012. So, right now it's operating well, but but we're concerned about how long it will last. So it's critical that we launch NPP now, Friday morning. So just to make sure that we have continuity of data sets. That's critical for operational product and services.
Further questions? Nora?
We heard in this press conference and the previous one about the major weather year it's been with the $1 billion and 10 events. Is there any way to quantify exactly what NPP could have done to help prevent some of that if it had already been in orbit? Or if, say, next year we have a weather event, weather year like this year?
Well, I was going to take, well,
It's a weather question.
NPP will provide additional information, so it will improve forecasting of extreme events several days in advance. Already, in 2011, during those 10 events, we actually predicted them pretty well. And so NPP, the importance of NPP is to maintain the accuracy of the forecast, and also there are improvements in the measurements, so we expect those improvements to be better.
Janine?
Considering the roller coaster this program has been on, you guys seem pretty calm. How excited are you to finally be this close to launch and seeing it get to space?
It's NPP. Anything is possible. So it's a really incredibly exciting time. I mean, I've been wandering around just looking at the launch vehicle and the rocket going, it's really going to happen. When we had the mission dress rehearsal and we actually got to 0, it was, even though we knew it was rehearsal, it was very exciting. I mean, it was like it was really going to happen. So when I got a chance to see the launch vehicle up close, it really does help make it real. So you're looking at the boosters and the bottom of the rocket looking. So we are very, very excited. And they have a large team of folks here and a large team of folks at Goddard, and the science community is really looking forward to this. So everyone's extremely excited.
Yes, indeed. We're excited. I'm excited. I've been associated with this program in one way or the other since like the 1990s. So it's been a long time. We're very excited to see the future capabilities or the upcoming capabilities of the new NPP satellite.
Right, we have some questions that have come in online. So Steve, if you could give those to us.
Okay, 2 questions from Mike Wall at space.com. The first one is, how many different climate variables will NPP monitor, and which of these are most important to or eagerly sought by the scientific community?
NPP will measure over 30 different climate variables. The most important is, depends on who you ask, but what we like to say is the most important ones are the ones that have the longest data records. So certainly the ones that carry on from Aqua and Nora are important, but in my particular discipline, which is ozone, we go back to Nimbus 7, which goes back to 1978, and even Nimbus 4, which goes back to 1970. So when you're looking for climate signals, the longer the data record it is, the more powerful it is, and the better questions you can answer with it. So it's the ones with the longest data records are the most important.
Okay, the second question is the NPP mission more valuable as a pathfinder for future JPSS satellites, or for the data it will gather itself?
That's sort of the first answer. We need to keep, the observations from NPP are needed for the forecasts today, as well as being another link in the chain of ongoing data observations. So these are observations that have been shown to be extremely critical, essential climate variables, and that we have collectively decided that they need to be continued to monitor from space, from NPP, JPSS-1, and hopefully JPSS-2 and beyond.
Any other questions here in the room? All right, that will conclude this briefing, and we have one more briefing to follow immediately. That will be on our ELANA CubeSats. Thank you very much, and we'll be right back.